Hello and welcome to 2008X, Fundamentals of Manufacturing Processes. I'm Professor John Hart from the Department of Mechanical Engineering at MIT, and I'm excited to lead you on this journey over the next several weeks. When we think about manufacturing, we probably think about machines and factories that produce so many things around us, from simple things such as Lego bricks to complicated electronic devices such as the smartphones that many of us have. We also think about advanced materials. This is a titanium fork that's designed for use on a camping trip, and titanium is lightweight and strong, so this will be easy to carry around when you go camping. And also we're seeing incredible advances in new processes, such as 3D printing, that allow us to eventually customize the things that we use to our individual bodies. We also have to think about how manufacturing of many things involves integration of multiple processes. In 2008 at MIT, our students design and manufacture yo-yos, simple toys, but toys that require the understanding of multiple processes and the assembly of parts that arise from those different processes. So now I'd like to ask for your personal definition of manufacturing. You may be uncertain at the moment, and that's okay, but please take out a piece of paper and write your definition of manufacturing in a single sentence, or send yourself an email that you can pull up later on when we're concluding the course. I asked this question to our students on the first day of 2008 at MIT, and as you might expect, I get a variety of different answers, but the answers all center around the idea that manufacturing often involves manufacturing of a lot of things, making a lot of things, and issues such as quality and cost, and delivering a product to a customer. Now, my personal definition of manufacturing, or advanced manufacturing as I like to call it these days, is the attainment of value at scale. And what I mean is that in order to sell something to a customer, you need to deliver value, whether it's a basic necessity such as food and water, or something advanced such as a new automobile or electronic device. And in order to do that and understand the manufacturing processes involved, you often need to be able to produce a large scale, a large volume. So many things that we use on a daily basis, because of the constraints of manufacturing, fall into this category of large scale and delivery of important value. Now, this might change in the future as we invent new materials and new processes, particularly 3D printing that lets us think about small volume production. But for now, let's run with it. And let's also ask ourselves, what's the difference between design and manufacturing? You may have studied design already and realized that design and manufacturing are different. But in order to produce something for a customer, you need to understand how to connect the two and the fact that design and manufacturing are very interrelated. So here's an example. It's a segment of a video taken at IDEO, a product design forum based in California. And about 20 years ago on television, they were shown going through an exercise of redesigning the shopping cart. So here are the designers going through supermarkets and asking the shoppers what they like and what they don't like about the shopping cart. And then they come back to their office and they brainstorm new ideas and they prototype these ideas quickly. And their ideas involve flexibility in the cart, so you can take the basket out and walk around and leave your cart in one place, and ways of scanning the items that you buy so you don't have to wait in the checkout line very long, as well as communicating with the store staff. So you could say check on a price or ask if they have anything more of a particular item in the stock room in the back. And this process of understanding a problem, having quick ideas and quick prototyping is an important part of the design process when you're faced with a challenge. And at the end of the episode, they unveil their prototype that looks quite nice and captures what they feel to be their best ideas. And to this day on their website, you can find this as an example and see these pictures of their final prototype. And you can see it has a lot of interesting features. These baskets can be taken out and stacked for easy storage. There's a communication device, and now we might use our smartphone for this to call the shop staff or to scan the objects as you go into your cart. And this is arguably the output of a very successful creative product design process. But now let's say what happened after the show. What did they have to do to translate this design to manufacturing? Several years ago, I was visiting Brazil. I was attending a research conference, and I went to a supermarket to buy a snack, and I found an interesting looking shopping cart. And I did some research, and it turns out that the shopping cart there that the customers were using is the actual manufactured output of that design activity. And you can see that they look very different. This nice-looking shaped metal cart with plastic and metal had to be reduced to a plastic design so it was more cost-effectively manufactured. But it still retained some of the important design features. The baskets were removable and stackable, and the cart is overall very compact and easy to maneuver in the store. Another interesting thing is that the carts there in Brazil were made from recycled plastic bottles, and that shows an example of how sustainability of materials is very important when you consider the life cycle of manufactured objects. And we'll discuss that later on in 2008X as well. So today we're thinking of manufacturing in many different ways, and I think manufacturing is exciting because it's related to our lives in many ways, and it's also advancing very quickly with automation and robotics, and also with the true integration of design and manufacturing. And among many examples, we can look to Apple and Apple's products, their notebook computers and their smartphones. And Apple is particularly outgoing in describing how their understanding of manufacturing is integral to their design process. For example, here, when they brought out a new version of the MacBook, they started to CNC machine the housing from a single piece of aluminum. And understanding the CNC machining process and knowing what cost and what scale it required allowed them to make a very nice-looking monolithic design that was very rigid for the customer. And this integration of understanding of true manufacturing process fundamentals with the capabilities that it can enable in design is integral to successful manufacturing of many products today.